Hi everyone! Today we are going to learn 12.4, which is find probabilities of disjoint and overlapping events. So the first thing we're going to talk about are probabilities of compound events, and there are two equations we're going to use for this. So if we're trying to find the probability of event A or event B occurring, first we want to look at those two events. If those two events are overlapping, which means event A and B could occur at the same time, we are going to use this first equation here. So if A and B are two events, then the probability of A or B is probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And this probability is just the probability of them both occurring at the same time. Now, if A and B are disjoint events, which means they cannot happen at the same time, we are going to use this second equation here, which is the probability of A or B is equal to the probability of A plus the probability of B. Now, before we get into our examples, we're going to review some key information about playing cards. So there's a total of 52 cards in a deck. There are 4 suits, which are hearts, and those are red cards, diamonds, those are red cards, clubs, those are black cards, and spades, those are also black cards. So there are 26 red cards and 26 black cards. Also, there are 13 cards in each suit. There are 3 face cards, which are the king, queen, and jack, and 10 non-face cards, which is ace through 10. So our first example here, find probability of disjoint events. So a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? So we have a little diagram here. How many 10s are in a deck? Well, there's only 4. And how many face cards are there? Well, we have 4 kings, 4 queens, and 4 jacks. So event A, we're going to say that those are the 10s. So what is the probability of selecting a 10? That would be 4 out of the total number of cards, which is 52, plus event B, which is what is the probability of choosing a face card, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 52. And these are disjoint events because you could not choose a card that is a 10 and a face card at the same time. So that means we're not going to subtract that overlapping event. So we're just going to add these two probabilities together, and that is equal to 16 over 52. And you can keep that like that if you'd like, or you can simplify it, and that does simplify to 4 over 13. Here is an ACT question. So a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a face card or a spade? So I have a diagram here for you. So event A is a face card. Event B is a spade. Now this time you'll see that there are overlapping events. You can have a face card and a spade at the same time. So we're going to have to use that first equation. So probability of A or B is going to equal the probability of A plus the probability of B and minus the probability of A and B occurring, that overlapping event. A and B. All right, so what is the probability of event A occurring? So we're just going to count how many cards are face cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 out of 52 plus the probability of a spade, and if you count all those up, there's 13 spades. And minus that overlapping event, and there are 3 cards that are both face cards and spades. So 3 over 52. If we plug that in our calculator, you're going to get 22 over 52. You can leave your answer like that, or you see that they're both even numbers, so it does simplify to 11 over 26. So I would accept either of those on the homework. Next, we have a word problem. Out of 200 students in the senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 students who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So we're first going to look at event A, and I labeled that as varsity athlete. So what is the probability that a student is a varsity athlete? Well, it actually tells us here 74 students who are varsity athletes, so that means 74 out of the total of 200 students. So that's the probability of event A. Event B is an honor roll, and we also see that there are 113 students. I'm sorry, not 113. There are 51 students who are on the honor roll. So probability of event B is 51 out of 200. And it does tell us that there are 113 students who are either varsity athletes or on the honor roll. So that would be the probability of A or B. So that is 113 divided by 200. So we want to figure out what is the probability that a senior is both a varsity athlete and on the honor roll. So this is the part of the equation we're going to have to solve for. So now using the probabilities that we know, let's plug in everything. So probability of A or B is 113 divided by 200. That is equal to the probability of A, which we said was 74 over 200, plus the probability of B, which is 51 over 200, minus, I'm just going to call this X, probability of A and B. It's just going to be some fraction. So to make this a little bit easier to look at, I'm just going to call that X. So now we are going to need to solve for X. Since this is a minus X, I can actually add X to each side to move the X on this side of the equal sign. And I don't want this over on this side of the equal side. I also want to subtract this over. So I'm pretty much switching this fraction with the X. So X is equal to 74 divided by 200 plus 51 over 200 minus 113 over 200. So now if we plug this into our calculator, you end up getting that x is equal to 12 over 200. You can leave it like that, or you can simplify to 3 divided by 50. And so that is the answer, and that is the probability of event A and B occurring. Next, we're going to talk about a complement. The event A bar is called the complement of event A, and it consists of all the outcomes that are not in A. And this is just saying that this little bar, you actually say A bar. So to find the probability of the complement of A, it's the probability of A bar, which you just take 1 and subtract the probability of A. So let's practice doing that here. So I want to find the probability of A bar. So if the probability of A is equal to 0.45, to find the complement, I'm just going to take, so I have the probability of A bar. That's equal to 1 minus the probability of A, which is 0.45. So if I plug that in my calculator, I get 0.55. That is the complement, and that is my answer. For number 5, probability of A is 1/4. So if I want to find the complement, or the probability of A bar, I'm just going to take 1 minus 1/4. And that is equal to 3/4. And I'm done. Number 6 here, the probability of A is 1, so the complement, or probability of A bar, is going to equal 1 minus 1, which in this case would be 0. In our last problem, probability of A is 0.03, so the probability of A bar is equal to 1 minus 0.03, which is equal to 0.97. And that's it.